All right, got recording going on, sharing the screen. All right, so just to make sure I reiterate, especially as you just sat down, Kelsey, right? The grade book was broken. It should be fixed. All right, so there are a couple things though that I've seen I did see the email, like as I said, it was Macy had sent, not Macy, sorry, Alexa had sent me an email for the factoring, right? Factoring trinomials. I'm gonna try to figure out why those don't get ported over correctly. But the Pearson assignments should be correct now. I'm gonna have to double check all my courses now because now I'm worried that the other ones were messed up. But if you had issues, though, so before I go move forward, then check chapter 2 as well. Make sure you go through the chapter 2, like just make sure that your grade, if you had issues with the grade showing up in Canvas, double check that one so we can make sure we're there. All right, going back to the material though that we're focused on, make sure you see we've been focusing on the division aspect. All right, I did a couple examples of long division. As we go forward, I'll make sure to do other examples of long division, but hopefully you see my emphasis isn't going to be on the long division. All right, as far as long division is concerned, it is important, and we're going to see it with rational functions, and I'll make sure kind of show it there. But for our class and the purpose of what we're doing, synthetic division is much more important to what we need to do. Yes, we could have done long division with this problem we worked on yesterday. But what I fit into one slide would have taken 4 slides for the long division. Okay. So there's examples of that idea of how much paper it would take, as far as writing stuff out. So we definitely prefer synthetic division. Now, please understand though, there is instances where you need the long division. Okay. So for today, we're going to focus more on the synthetic division. So I got a couple more examples there, and then we're going to go through and just make sure we see again, how does this all come together, right? Make sure we remind ourselves that as we practice this, what is the piece that this gets put into, okay? With that said, I have 2 problems here where let's do this division to divide. So when we're done with it, make sure we know how to identify the quotient and the remainder. The second problem there says evaluate the polynomial function using synthetic division and the remainder theorem. Okay, so for all 3 of these, we better have some synthetic division.
Oh, I read that wrong. Yeah.
Huh?
I read it wrong.
Did I divide something or divide something?
No, I did the long division, so I didn't read it right.
Ah. All right, so jumping into this, what does the synthetic division symbol look like? All right. That's how I describe it. It's like an L on its back, right? Why do I put the second little box there though? Right, so make sure we remember here, this is the remainder. That's what we're reserving that for. Now, with that said, am I allowed to do synthetic division with this particular problem? Why is it that I'm allowed to do synthetic division? You talking about this here? Right, so what would you get if you did that? -5, right? Now, what does that -5 represent, right? That's my K value, so we're fine. Now, remember the question I'm really asking, does it match that X minus K form? And yes, it indeed does that. Now, if you remember to take the opposite sign when it's in a factored form, you're fine. But if you forget again, that's a great way to handle it. Set it equal to 0, right? Now, this only works though when we're in this X minus K. That means no coefficient on the X. It's just X. Okay, so if I came over here and put something like, hey, 2X plus 3, we would no longer be able to use synthetic division. The good news is we can find ways around it though, okay? We can find ways around it. The big one though that we definitely don't want to use is like, say I gave you X squared minus 5. We definitely will not be able to do synthetic division here. Now, if you want, I'm pretty sure Mr. Simon has some videos on YouTube that shows us how we can do that with a quadratic if you want to learn that, but I'm not going to do that for this class, okay? With that said though, Are we good with why I'm putting a -5 over here on the outside? And -5, as we mentioned, right, said x plus 5 equal to 0. If you solve it, our k value is what we find there, -5. The factor in the 0 kind of connection that we were talking about. Now, I'm not asking if this is a factor or specifically trying to find 0 here. All I'm saying is let's do the division. What do we have to be careful of, though, with the polynomial when I go to fill in the inside part of this? It's descending order. So we have descending order, right? It goes cubed, x, and 11. What else? What's missing?
The X squared.
The x squares. Everyone see that? So we need to make sure to put this as 3, 0, -7, and 11. This is very important here, is you have to recognize it went from a cube to an x. So there's no x squared there. So we need to fill it in by putting the 0. Okay, that's what we're focusing on. It's very important, though, because if you don't put it, then you will not get the correct division. Right? The idea behind that is each of these terms represents something. X cubed, x squared, x, and my constant term. Now, what do we do for the division? What is the algorithm for synthetic division? Bring down the 3. So we add and multiply, right? That's all we do. We add and multiply. Now, the 3 we bring down because nothing was there, right? So technically it's like 3 plus 0. So when I do that, though, my next step is the multiplication. So what's that going to give us? -15 and then 75. That gives us what, 68? And then -340. Which is what, -329? Are we in agreement here? Now, our focus right now is we're trying to identify the quotient and then whatever the remainder is. Now, our remainder is going to be a constant value. Make sure you keep that in mind here as we deal with this. Our remainder is a constant value because we're doing synthetic division. So our remainder is just a -329. But what do I need to do with the quotient?
Minus like, so minus the x,
Mhm.
like x cubed by the x of the -5, you get x squared, x, and then a constant.
Right, so they're dropping each of the degrees by 1 degree, right? So we would write that as 3x squared minus 15x plus 68. Any questions or concerns with that one I could clear for somebody? Now, just make sure, I think I have the old test on here already, so let's go look. There's the one problem, as I mentioned on the test, that will say use long division. All right, does everyone see that? Now, as far as this other stuff, this is the problem it's going to tell us to use synthetic division, but make sure you see here, this is the one with that we're about to do in a second by evaluating the function. I just put the directions opposite of what I had on the this today. Okay, so we're going to copy that one, but make sure you see here, this one here, I don't necessarily use synthetic division. You have a choice. So I cleared everyone. But make sure you see here how many times you see the synthetic division up there. 3 times. Right now, what you're gonna find is being able to identify the remainder as well as the quotient will be an important part of that process. Okay, so that's why we're practicing this now, is because as we saw yesterday with the problem we worked on, we're gonna need to be able to work through a problem. That's where identifying the pieces is very important. Now, with that said, I could easily just said, hey, use division to divide this, and you have a choice. The difference is this has that x squared involved. That's why you have to do long division. Okay. But again, the focus here is the quotient and the remainder. Okay. The quotient and the remainder. The key to remember with this statement, as we talked about yesterday, is that division right process. We put the remainder over our divisor. Okay. Kind of give you an idea of what to expect for the test. Now, the rest of that test is focused on rational, so we'll get there after we finish up polynomials. Now, so everyone's okay with this first one. Let me shrink that down a little bit. All right, what's going on with the second one that we have to be careful of?
There's not the same.
All right, does everyone agree with that? Separate this. We got to rewrite our problem here. The ascending order just says take those exponents and write them biggest to smallest. Do not change the signs of the terms, just reorder them. Now, can I use synthetic division is the next question. All right, so it goes back up here, right? That whole idea that we have x minus k, so again, we're good here as far as that's concerned. What is my k value though? All right, make sure to change our sign. If you get stuck there, just remember, hey, set it equal to 0, then solve, right? Doesn't have to be a guessing thing. The key is what will make x minus 3 0 is what we're focused on. That's why we're picking 3. From there, we can jump into it. Just this one's going to take a second longer, right? We have our 3 on the outside, then we'll 1, -1, 3, -5, 19. I don't think I missed anything. The only thing that's taking longer is it's x to the 4th rather than x cubed. Right? That's one of the nice things about synthetic division too, is I could start giving you like say x to the 7th. Yeah, it's going to be a little bit longer, but that's definitely going to take a lot less time than the long division does. Okay, make sure you saw on the test, that previous one, that long division, I've had it down to like 1 or 2 steps. Right? So for the test, it won't be something that takes forever. Okay. But as we go through this process, we do want to be careful to.
Wait,
Why did I write 3?
I did the same thing. That's why I was like, wrong.
Let's make sure I'm not going too fast again, right? Bring down the 1, 2, 9, 27. Is this in agreement with what y'all see? You got 85? Sorry. Do we feel okay with that process? So this is definitely something important we need to be confident with. But hopefully what you're seeing, the good news is it's just adding and multiplying, right? But we have to remember that going through step, as I go down, I add. So everywhere we go down, we're just adding the numbers that are stacked. When we work our way back up, that's where the multiplication comes into play. All right. What I find people struggle with this as far as like tests are concerned, as I highlighted before, watch out for those missing terms. That definitely is one of those things we have to be careful of. As mentioned with this problem, make sure you see the importance of what we started off by doing here, by taking our polynomial and making sure we rewrite it in the proper order for division purposes. Okay. Which kind of try to keep in mind too, from the first test, I've tried to say, hey, the best thing to do here is write it in descending order, right? We didn't need the degree of a polynomial then, but it helped us, right? To know the order of the terms, how many solutions an equation would have, right? There was information that still helped us then, okay? So what is someone putting for the quotient?
X cubed plus 2x plus 9x plus 2.
Are we all in agreement here? Everyone okay with that? And then our remainder, 85. Now we should expect a constant value again because we chose synthetic division there. Okay. Any questions? All right, does this problem completely change everything? So it's a fraction. Does that mean we can't do what we just did though? All right, just know that we're gonna have to deal with a fraction, right? And that's gonna be something we do need to be comfortable with, is dealing with fractions, okay? This is college algebra, right? Fractions are fun. But as someone is setting this up, what is it? What's something that stands out to you?
We can't equal to zero. The other one was like x minus 2.
Right, so what does that mean when it already gives me x equal to a value? Use that value, right? That's the part that we have to remember. If I have it in a factor form, I have to change it, right? But if I'm giving you the x value, we don't have to change it, okay? It's only when we go between the value in a factored form that we see that change take place. Right, so that's definitely like just put -1/2 on the outside, but what's going on the inside that we don't want to overlook? We got -2, we have 7, and I put -13, right? Where's the 0 go? We have x cubed, we have x squared. We don't have an x term, right? There's no linear term here, so we need to put that 0 and then the -13, okay? Now, how many feel like because it's a fraction, this is gonna be the worst thing you ever worked with? All right. Don't let fractions do that to you. Thankfully, nice. I picked 1/2 for you, right? But as we go through this, make sure you see that as you bring down this -2, what's 1/2 times 2?
1.
1, and the negative times a negative is a +1, right? And what's a nice, yeah, which is nice, right? 7 plus 1 is 8. That's nice because what's half of 8? 4, right? And then 0 plus -4, -4, and half of 4 again is just going to be 2. Right? And it was -4, -1/2, so that's why it's +2. So lastly, though, we'll get -11. So was the fraction that bad? No. Now I will say this, when we are using this for the sake of working the polynomial, if the fraction's not working out nicely, it's probably not something we want to continue with, right? And I'll kind of make sure to point back to that one that we did yesterday, okay? But what is my conclusion that I want to use here when I say evaluate the polynomial using synthetic division and the remainder theorem? So what are we going to conclude that f of -1/2 equals? What does f of -1/2 equal to? Not the quotient. The remainder theorem states that f of k equals r. So it's -11. This is the part that we have to remember, that whenever I see that remainder theorem piece, right? So the second I see remainder theorem, maybe we then need to write this down right next to it. So you see remainder theorem, just get up there and say, hey, f of k equals my remainder. And look at that, they already told me my k value. That would actually help you see that -1/2. I just use that -1/2, that's k. All right. So as we go through that though, make sure we see that connection then, or I just bring that over and I'm done. Which hopefully was solved like from the test perspective, right? I had the problem that said use synthetic division to evaluate, right? Well, here's your example. Can you do synthetic division? All right. The key there is just make sure to know where the remainder is. The way that we show that we know the remainder is, hey, whatever I just did, that equals the remainder. Okay. The other problems with the quotient, we see that more with what we saw yesterday. As we work through a polynomial function to find zeros, that's where the quotient comes in. So that's why we need to review the first two. So is there any question on the different ways that we need to interpret our division? Is everyone okay then with this aspect? All right. Well, with the last couple minutes that we have here, let's look at a function, right? Let's work through this. What type of function is this that you're about to start writing down? How would we describe this function? It's not quadratic, right? Quadratics have what exponent? What does this one have that we have to watch out for? A 4. It also has cubed, right? So it's, but what's the broader umbrella? It has many terms, right? So a quadratic is part of this, but quadratic is very specific. So what is the term we give to quadratics, cubics, and above? Not multiplicity, that's for like talking about factors and zeros, right? Make sure you see here that this is a polynomial function. Right, the key is we had what, 5 terms? We have many terms here, right? All our exponents are positive integers. Those are other important parts of that, okay? With that, what's something that we should be able to describe, right? So I gave us the hint here, but if I told you to sketch a graph of the polynomial function, this is stuff that we need to know to do on our own anyways, right? Now, of course, on the test, I'll say, hey, make sure to identify this stuff, okay? But if I ask you to also sketch a graph, this is important stuff to identify. All right, so as we work with polynomial functions, make sure we do this, right? So what's the degree of this polynomial function? Does everyone agree with that? All right, what's the leading coefficient then?
4.
They're both the same? Is that okay that they're the same? It just happened to be the coefficient's 4 and the exponent is 4, right? Now, what about the leading coefficient do we want to make sure to take note of?
If it's negative.
If it's negative, pause, right? It's positive here, right? So just kind of make a little note to yourself like, hey, no reflection. All right. Now from here, we can get the next 2 pieces, right? So let's stick with the one that we could do more quickly. What is the maximum number of terms? All right, why is the max terms 3, y'all?
Because 1 minus 1.
Right, so we take our degrees, right? 4 minus 1, okay? Now, the end behavior takes a little bit more work, right? So we have to look at this like, hey, here's the end behavior of f. And remember, all this is saying is what's the edges of my graph going to do? We have the left-hand side, which remember, we'll write this as x approaches negative infinity. We have the right-hand side, which we'll write as x approaches positive infinity. Okay, left is negative, right is positive. Now, the key that we want to take first, though, is are our 2 ends going to be the same or different? Okay, and the graphs that we use to help us with this are going to be that parabola and the S shape. What was this for? What was that? Y equals what? What functions have this graph? Quadratic. So just remember x squared. But that's make sure we see that. Just don't overthink it, right? Go with that. Hey, that's just x squared. Well, what's the next one then? That's my x cubed, right? And these, even if you have to sketch these out real quick to remind yourself, that's great. Why do I like these? Does this graph of f of x going to look like either one of these? Probably not, right? There's probably a lot more going on, and that's what we're trying to figure out, right? But from the basics, right, we know that, hey, if we have an even exponent, if our degree is even, it's going to match the quadratic. If our degree is odd, it's going to be similar to the cubic. So should the 2 edges be the same or different? is what we can look at, because make sure you see here that when we look at this, these are both rising, this one's falling while that one's rising. That's all our focus is. So should they be the same or different? The same. So that would be one thing I feel would be a great way to start, right? Hey, both these are the same. Now the question is, do they both fall or both rise? I think you were saying that they were both rising. Why would you say they both rise? Trinity. Why would they both rise? What did I make note of that would help us with that? It's because it's positive. What's positive, right? Not the exponent, the leading coefficient. That's why I always put reflection or no reflection, okay? Make sure you see that. That's why I say at this point, make sure you write reflection or no reflection. Okay, no reflection means that my graph could possibly look something like this. Now, what did I do here that also took in another important part, right? Make sure you see here, I kind of made more like a W shape so that it had 1, 2, 3 turns, right? Make a quick sketch, just kind of like, hey, both ends are going up because there's no reflection, right? But make sure you see it's because not the leading coefficient is positive. That's exactly what we're looking at, right? So that means both sides should rise. But how did I say we should write rise? Or another way that we could write rise? The function itself approaches what? What values are up? Huh? Positive infinity though, right? I don't know why I kind of gave away the answer earlier. Huh? All right. Make sure you see here though, that's just us jotting down information though, right? Us just kind of quickly saying, hey, this is where we're starting from. We have kind of a general idea. Now we need to take a step forward and start finding some other things out, right? So once we jot down these things, we have our degree, we have the maximum number of turns because of our degree. We have our leading coefficient, and whether or not there's a reflection is definitely one aspect we take from that. And we know that when I go to draw my graph, both ends are going up. I just got to go figure out how it turns in between. That's where the next step comes in, right? Where I talk about intercepts. What intercept should I find first, though? I would say the y-intercept, right? Remember, x-intercept is going to be work. The y-intercept is what value?
-6.
Is -6, right? So as we move forward, we're going to talk about this on the next slide. Remember the importance of both of these terms. Those are really important terms. We saw this one already in what we did here. Okay. This -6 impacts the y-intercept right away. So make sure that as you're doing this, make sure to remember the y-intercept, I can kind of just state real quick. F of 0 is whatever my constant term is. If you don't have a constant term, what number is represented? So if I gave you something that looks like, hey, x squared minus 3x, you don't have a constant term, right? That means then that f of 0 is 0. You don't have a constant term. Okay, so make sure you keep that in mind. All right, but I feel like this first slide, though, I wanted to make sure to see here. It's like, hey, as I read this problem, what are some things that I can start jotting down to keep track of, right? As I state my degree, I can state my leading coefficient because I was already looking at 4x to the 4th. After you state your degrees, though, you could also then just go state the maximum number of turns because it's one less than the degree. The next step then is to take that leading coefficient and the degree to talk about the in behavior. Okay. From there, we can start finding stuff in between. So that's why I say make sure to state the y-intercept now, but to get the x-intercepts, what in the world do I need to do here? Okay. Set it equal to 0, right? So now we're trying to find the zeros of the function. Am I going to be able to factor this by grouping?
No.
Right. And 5 is definitely more than 3, so I'm not going to be able to do that as far as dealing with this. I can tell you right now, if you look this up on some software, you can find some software that'll factor for you. But guess what? That's not going to be something we all recognize when it comes up. All right. So make sure you understand here, this is where we come in with the synthetic division. Right. Now, what are the numbers, though, that are important to me again? Because that doesn't change. right? The same ones we just highlighted, right, are the ones that we need to work with. But remember, this is where we're going to move forward and say, hey, what are the possible rational zeros? Now, I'm just going to put PRZ for right now, but make sure you see that yesterday. I just said possible rational zeros. Okay, these are the numbers that could work. All right. Everyone's good though with what I'm going to be putting PRZ for? All right. Now, the reason I want to make sure to say it that way though, PRZ is just a quick way to just be like, hey, I'm writing out possible rational zeros. But this is where we have to go back and then and say, hey, I want the constant term and the leading coefficient. And we're just going to start listing factors of those. So what are factors of 6?
1, 2, 3.
All right. And that's all of those, right? Now, with that said, though, I need to move forward with this because I also have this 4th here, right? So what we need to do is break down the 4, right? The 4 is going to be 1, 2, and 4. Now, make sure you see here, I wrote out the fraction already. Okay, so what we need to have here is something like, say, plus or minus 1/2 and plus or minus 1/4. I took the 1 and I put it over both of those. All right, well, now we need to do the same thing with the 2. But what is 2 over 2 equal? All right, so do I need to put 2 over 2? No, because it's already here. All right, what about 2 over 4? Do I need to put 2 over 4? What is that equal to? Right, so I wrote that right in front of it already, right? So make sure you see here as you do fractions, make sure you simplify so you're not putting more than you need to, okay? However, when we get to 3, well, guess what? I don't have 3/2 and 3/4, so I could put that. All right. And that's just me taking factors of 4, right? 1, 2, and 4. And I'm not doing 1 though, because anything over 1 is itself. That's the whole first list that we put is everything over 1. Now make sure you see here again, I'm not going to do the 4 though, because 4 over 2 is 2, and then 4 over 4 is 1. So I don't need those either. I only needed to do the 1 and the 3. Now with that said, will any of these guaranteed to work? Are any of these guaranteed to work? No, that's the whole point of me saying possible rational zeros. None of these are guaranteed to work. You need to keep that in mind. Also, with that said, does that mean I need to go start doing my fractions right away? All right, so what do I do then? Where would someone like to start?
2.
Is it going to work again right off the bat?
I don't know.
All right, so let's try 2 to see what happens. Now, make sure you see here, we took our list of possible zeros and I just pulled something from it. What I don't recommend doing is jumping straight to fractions. And I don't recommend using the highest value, like 6. Don't use 6 right away. It's not going to be, it can work now, right? It is a possible rational zero, but it's not typically going to be the one that's used all the time. It can work though. It will happen from the time to time. I personally usually start with 1 or -1. Okay, and then just work my way. Nothing wrong with picking anything you want though. If you want to start with -3, go ahead and do that. Do what you look at and what stands out to you. Picking with the 2 though, let's see what happens. The 2 work? Now, did you completely waste your time though? Do we completely waste our time when it does not work? What does this represent here? Where did we get that from? That was our function, right? So make sure you see here. This is f of x. Because of that, we now know that f of 2 is equal to what? If I plug in 2 into my function, what does it equal? -64. So understand, make sure you note that. Like, hey, it's not 0, so it's not helping me here. But you found a point you can use for graphing later. Now, will I have you graph such a point on the test? No, but know that that is a solution to our graph, okay? Are we good with where that's coming from? So did 2 work? No, because we wanted what? We wanted a remainder of 0. So what's another number? Someone else? Huh? -1. Let's try -1. Did -1 work for us, y'all? Does that mean it's completely wrong? No, because again, we're still doing it. So make sure you take a note here. We found another solution, right? What someone else want to try?
3.
3 worked, I'm guessing.
Okay.
Let me shrink these a little bit. Now make sure you see here, this is where us practicing and making sure we're confident with our synthetic division skills become very important, right? It's just something we want to do quickly. Make sure you also see here, as I go through this, we can start scratching off the ones we know didn't work. So we don't want to use -2 anymore. We don't want to use -1 anymore, right? Let's see what happens with the 3. One thing I'm looking at though as I do this is that -23. What are we going to do to get that -23 a little bit smaller, right? Because we got to deal with that 6. So that's one thing we want to keep an eye on. So I'm liking what we have here. All right, 4 becomes 12, 8, 24, which is 1, which is 3, which is 2, and there we go. We like the 3. Now make sure again you see here what that means is f of 3 equals 0. Okay.
Right, I was just gonna say, what's like the 3s?
I need to be more original is what it means. Okay. Now, if you would have picked 3 right off the bat, you would have saved yourself some steps, right? You would have done 1 synthetic division. Now, like I said with myself, I might start with 1 and work my way through. Okay.
So like, how would we have enough time to do this? Like, all of those numbers? Like, if you have to plug in like a negative,
Should you plug in every single number?
like, I don't know how to know which one is the right one.
All right. So look what I did here. I started with 1. 1 did not work, so I went to 2. What happened when I got to 2? It worked, right? So understand that on the test, I have to keep that in mind. So I'm not going to put probably a problem where it's going to make you go through all that and it's all the fractions. I could make it to where all the fractions are the zeros, right? We definitely can find ways to do that, but understand that with that perspective, for a testing purpose, I have to keep that in mind. Okay. I do have to keep that in mind. Because what's happening, we're not done here, right? How many zeros are we supposed to be finding? 4 of them, right? I didn't want just 1, I want 4 of them. Well, watch what happens here with this one. When I get to this, I need to write this as x minus 3 times the quotient, right? Make sure you see here the quotient though is going to be 4x cubed plus 8x squared plus x plus 2. All right. Now remember, our whole focus here is setting this equal to 0, right? X minus 3 equal to 0, we've already dealt with that. We do not need to do this. We already confirmed that. What we need to focus on is what's going on with that quotient now. All right. So what happens if I take this quotient and I set it equal to 0? Well, what do you recognize about the quotient here?
Factor by group.
Let's try factoring by group because it looks like it's going to work to me. So like with your concern there, this would be something to watch for, right? That now trust, if you didn't pick three, it may not factor by grouping, right? It might just be because we started with three that we could do this. Because yesterday, we were not able to factor by grouping. Right? We had to do synthetic division to the quadratic. Make sure you see that. Factoring by grouping did not work here. Okay. So we had to continue with more synthetic divisions. This one took us longer than it did today. Right? So just keep in mind that on the test, this could take you a while. Okay. That is something that we do have to make sure to acknowledge with this. Where am I at? Totally lost my spot. Right, but make sure you see here though with the factoring by grouping that we have going on here. What's another number that would have worked? Could have tried -2. We found that the 3 worked, -2 would have worked, right? But what's going on with this one that we should definitely recognize, okay? Make sure you see there it's quadratic. It is not factorable though. There's no GCF, it's not a trinomial, it's not a difference of squares. So here what we want to do is subtract the 1 from both sides and then divide both sides by the 4. Okay, what does that allow me to do when I do that process? I got the x squared by itself, right? But I need to do what to get it to be just x? That's where the square root comes in. Now make sure you see here that square root's still nice, right? 1/4, hey, the square root of 1 is 1, square root of 4 is 2. What's a couple of things here that we need to make sure we put? Don't forget our plus or minus, right? 1/2. Is there anything else? Why do we need the I here? All right, the I shows that it's complex. With that said, we're done. How many zeros did we find, right? We found our 4 zeros. What was the question I asked us to find here, though? I didn't say find zeros, I said find the intercept. So make sure you see here, we had the y-intercept already. We stated that beginning. Those would be the only 2 x-intercepts we have. Okay. Now, what I would say here is if you picked -2 here, you would have been able to factor by grouping again as well. Okay. So keep that in mind. This is something though that I understand from a test standpoint that, hey, we need to know the process. That doesn't mean I'm going to put x to the 7th on the test. All right. There's got to be reasonable stuff in there, but on the test, you will need to go through that process of finding one that works and then using the quotient to continue forward. It will be needed, whether it looks like what we did yesterday or what we just did today. Make sure you keep in mind, you will need to use the quotient. Okay. Now, make sure you also note here that these are zeros, right? That's the other 2 zeros. I didn't highlight them, those are not real numbers, right? Since they're complex numbers, they're not intercepts. Okay. But that is all we have time for today. It is 10:50, so have a good day. Before you head out or while you're heading out, let me close this down.